the law of conservation of energy. This is such an important concept in engineering. You know, lots of engineers, you have to understand how energy transfers occur in order to design things. I spend a lot of time with the class on this, and it's also a lot of prep work. In terms of prep work, I have my own single copy or single piece of equipment that I know ahead of time to show the kids as an entire group. Then I prepare a little bag for the student-led demonstrations, and then I prepare a little worksheet for their 8th grade demonstrations. The first thing I do before I do anything else is I pull all this stuff out of my closets. For my own stuff, I have a generator board, I have perhaps a radio that I've used in the past, I also have a fan here that I've used in the past, and I always pull out a bimetal bar. I'll tell you more about these bimetal bars in a little bit. I introduce to the class this problem about, you know, energy cannot be created or destroyed, and then one by one I kind of show the kids about how energy transfers occur, how energy can be converted. As soon as I feel that they have a pretty good grasp on it, I will either give them an exit slip to make sure that they get it, or I'll have them do some type of a writing so that I have a good feeling that they are understanding this, or at least I know who to scaffold. The second piece of this is where I ask them to pretend that they are demonstrating this to a group of 5th graders. And the prep for this is huge. I take these little bags, I number the bags for each of my tables, and I stuff the bag with all kinds of toys. I have a tech deck in there, I have a super ball in there, the rubber bands, of course this one broke, but usually I have a rubber band in there, and I have these little toys. I have a ton of these little wind-up toys. Because, oopsie, does this one not work? Let me go to this one. I just finished this, so it's like, oh, there. Fun little wind-up toys. Cars, all kinds of things. And I say to the kids that they are going to demonstrate the law of conservation of energy to a group of 5th graders. And they write down exactly which demonstration they're going to do. And they've gotten really creative on it. So, for example, they might put a mouse on here and then make it go and then talk about how the energy gets transferred around. Usually it's been very successful because of 2 reasons. One, they're playing with toys, it's all hands-on, and 2, most of the demonstrations that the kids do are mechanical to mechanical, and that's on purpose. I want them to see how the mechanical engineer is the engineer that we have a lot of, and almost every single factory, every single, almost anything that builds something has to have some type of a mechanical engineer because they're studying that energy transfer. I also then, the third part, I give them the words cell phone, microwave, television, tell them 8th grade examples, and in those examples they write down from an electrical perspective what the energy transfers are going to go to. The energy transfer I hit not rarely, but I hit not very strong is the radiation one. I have a radiometer which I take outside because my room is right outside an entryway. So I just take the kids outside, we talk a little bit about a radiometer, and that's how I hit the radiation energy. So having all of these different things really helps in these demonstrations, and then giving the kids these hands-on demonstrations, and then generalizing over to here is an 8th grade example, or you're in modern day electronics. They also get an idea of how a simple mechanical to mechanical is developed along the way, so that now with my cell phone I have electrical, I have radiant, I have sound, I have mechanical and the vibration. They just love to think about that. And it just really brings home that idea that this energy is not being created or destroyed, but that instead it is being transferred. I want to talk about 2 things because they're pinnacle. I always give the kids a reflection statement, and you'll see in the student, you'll see in my student samples that I ask them, I understand the law of conservation of energy because, and they have to give the example of where their aha moment was, which was the one where they really truly understood it. Most kids say one of 2 different things. They say either the generator board, where we went from mechanical to electrical to thermal and radiant, or they say the bimetal bar. So this is a bimetal bar. You can get them at science stores, and basically it's 2 different metals. I think copper and I think titanium. And I curl it up like this, and then I get a candle, and I have the kids, goggles. I have enough of these so that each table gets one. I do a teacher demonstration before I just let them have the fire for obvious reasons. So I'll give them, they all have a bimetal bar, and then they'll take the bimetal bar and they'll put it underneath the thermal energy, and the candle will create the thermal energy, and basically what it does is it loosens the electrons on one side and only on one side, so it begins to curl out, it begins to uncurl. I can't tell you how many kids said to me that the bimetal bar was the one where they like, now I get it. Okay, now I understand how this transfers. When I talked about the generator, I also said that this is one where they're like, yeah, now I get it. And that's because at the end of this little generator board, I have 2 pins or 2 screws, and we all form a circuit. And I turn the crank and give them a little electric shock. I make sure that it's safe. Everybody, if they don't want to do it, they do not have to do it. And most of the kids did it in the 7th grade with their physics unit, so they're kind of familiar with this activity. So I don't feel like I'm taking any safety out of it. But again, by doing that, they actually feel the electricity. And we talk about how you can feel it come in this side, how you can feel it kind of go out that side. And they can really get a good emotional sense of the law of conservation of energy. The assessments went really well. I just did a formative assessment on the student-led demonstrations. I also did a formative assessment on the 8th grade demonstrations. And the summative assessment was a 3 to 5 sentence summary. And in that summary, as I said before, it was quite simple. All they had to do is tell me why it is that they understood the law of conservation of energy, give example of a demonstration that was their aha moment, and just that was really about it. So for the most part, those went really well. The only issues that I had was the kids whose writing skills were just not good enough to give enough details. And so when you look at the student samples, you're going to see where I'll have a note on there that'll say, you didn't quite get this, see me, or something to that effect. My philosophy is I don't let anybody fail. So if a kid didn't understand it the first time, I like to give them the opportunity to come back to me, explain it better so that they can get a better grade on that. On those CMEs, I worked with those kids individually while the other kids were working on another activity. I talked to them about it, and most of those kids understood it. They just didn't know how to write it. And that's what I kind of helped them with. What words do you choose? How is a better way of saying this? Or a lot of times a kid will read it and go, oh, I meant this. I'm like, okay, good, then let's write that. So overall, it went pretty well, and I can tell you that of the kids, of the 90 kids that I teach, I had 2 that still did not understand it. Both of those kids were absent the day that we did the demonstration, and both those kids are coming in after school so that they can get that learning and get that grade up. So it's a great fun demonstration and lesson. Thanks.